Our question states the following. Before anything else, let's define the probability of heads and tails. Now, let's see what our question asks for. We must find the probability of getting heads on the first coin toss given that I won. Let's call heads on the first coin toss FH, and I win as IW. Thanks to Bayes' theorem, we have the following. Let's work with the intersection form of the numerator. This intersection accounts for each outcome where I win and the first coin is heads. But first, let's take a look at a sample of outcomes where I win. The first outcome where I win is the simplest one, consisting of only 2 heads. The second outcome where I win consists of 3 coin tosses. It must start with tails, since it is not possible for a sequence to have 3 consecutive heads. Note that it is not part of the intersection we saw earlier, since it does not start with heads. The third outcome where I win consists of 4 coin tosses. It must start with heads, since 2 tails couldn't be observed if I won. Note that it start with heads, so it is part of the intersection we saw earlier. We can continue following this pattern as long as we want. There are an infinite number of possible outcomes where I win. Let's highlight the outcomes that belong to the intersection we want. These are the ones that start with H. The probability of the intersection is the sum of the probabilities of each of its outcome. We can't consider all the infinite probabilities here, but let's see if these probabilities follow any pattern. Note that it follows an infinite geometric sequence. Therefore, to sum all of them, we just need a simple formula. A1 is the first term of the sequence. Here it is P of HH. R, the ratio of the sequence. Here it is P of HT. Now, let's update our main equation. In order to finish our main equation, we just need P of I win. So, let's take a second look at our sample of outcomes. Note that to find P of I win, we need to sum the probabilities of each of these infinite outcomes. We already have the sum of those that start with heads. We still need the sum of those that start with tails. Note that they are also an infinite geometric sequence. A1 is the first term of the sequence. Here it is P of THH. R is the ratio of the sequence. Here it is P of TH. Now we can find the P of I win. With that we can complete our main equation. Let's get rid of common factors. Remember that Q is 1 minus P. There we have it.